everyone, my name is Dina Ayman. I'm a program manager, and today with me I have Augusta Regetto, who is a software engineer. We both work at Microsoft on a very cool technology called WebRTC, which I will get into in a little bit, but today's session is about taking that power that we have inside WebRTC and being able to use it on your modern Windows apps. And that's something that we like to call WinRTC, not web, but WinRTC, which kind of means Windows, you know what I mean? So today I will talk a little bit about the history of WebRTC in case you're not too familiar with the technology. I'll show you how cool it is and what it can enable and why it's important to have a solution like WinRTC available to be able to use this powerful technology on Windows and more than just the browser, which is the really cool aspect that I will get into. And to kind of make it real, we're going to talk a little bit about the current customers and what their scenarios are, and we're going to get into the technical aspects and show you the architecture and the demos, the really, really interesting things that we have built, and we want to show you how you can build it yourself too. And we're going to conclude with where we're going next and what you should expect moving forward. So what is WebRTC? WebRTC stands for Web Real-Time Communication. It's a standard to have a real-time communication whenever you have a web browser. It's awesome that it's free, open source software. It allows developers to build powerful video, audio, and data communication solution. And believe it or not, it's used on a lot of the things that you probably use in your daily lives. It's used on WhatsApp, Facebook Messenger, Amazon, Skype, Blackboard, Mixture. It's even used on Microsoft products like Teams. If you ever use Teams to join a meeting on a browser, that is powered by WebRTC as well. It's a Google code base, and its reference implementation of the standard was actually in Chrome, but is also available on Edge, iOS, Android, Opera, and Safari. So where have we seen WebRTC? WebRTC is around you everywhere right now, especially right now, having to deal with COVID-19. We see WebRTC in so many industries, saving so many lives. I personally have used WebRTC in telemedicine. My brother was recently diagnosed with diabetes, and the only way we can connect with doctors was through video and audio conferencing. I'm so thankful that we have a technology like WebRTC that we can deal with hard situations like that. It's used in education. I've seen that with my own siblings, and they feel great about the education they're getting, and they feel connected to their professors and their teachers in school. And broadcasting, like news shows, or if you're watching anyone broadcasting stuff in their homes, that's also using WebRTC. It's also used on emergency cases, very critical cases like emergency, to get real-time help, to really help with critical cases like emergency. And that's used on something that is called Data Channel on WebRTC, and it's amazing what it can do. It's also used in traditional ways like remote support or screen sharing, or even simple file sharing, to be able to get the experience, to get the help from someone that is not there with you. So as a whole, WebRTC is a really, really powerful technology that is helping with this situation that we're dealing with on our daily lives. So the reason I'm telling you all that is because WebRTC was only possible on browsers on Windows, and we heard from our customers that they want more. They want to see WebRTC technology outside the browsers. And we have seen an opportunity where we can help our customers achieve more and get more than what they're getting right now in WebRTC. So the very first thing we did was something called WebRTC UWP. And that was our first attempt. That was something you might have heard about it or might have not, but it was used by a lot of our different customers, and they got web real-time communication outside the browsers on Windows. But when we did that, we really targeted UWP support, Universal Windows Platform support. And even though it was used by many of our customers on internal and external products, it was made of 40 different forks on GitHub. 40 different public repos that it was mostly forked from the original Google code base. And that made it very complicated to be in sync with the very with the Google code base. And it made us think that we can do more. We can help our customer achieve more. And we wanted to provide developers with the best cutting edge features. And we thought it was time to work on the next gen. And we are now introducing WinRTC, that is original, not forked Microsoft library for WebRTC communication, to bring WebRTC to Windows in more than just the browser, outside the browser too. So some of the principles that we targeted when we did WinRTC was to make it easier, or at least easier-ish. Easier for our developers to use in so many different ways on Windows in more places than what it was targeted for. A lot less code, a lot less integration pieces that you have to deal with, a lot less packages that you have to install. But we also wanted to make sure that we're closing the gap between Win32 apps and UWP, and that's what we heard from our customer. And we think we have done a great job with this, and Augusta is going to show you how better it's gotten and how great it is right now in the demos. But also some of the other principles that we also targeted was compatibility or key interoperability, to allow developers to call any web native APIs, but also be in line with the community standard, to be on the same page with the original Google code base, to be able to keep with the interoperability to cutting edge web browsers. And that was also to contribute back. So all of this doesn't make sense to us if we're not contributing back the community standard. So let's get into the real business. I'll show you who our current customers and how they're using WinRTC to solve their problems. So the very first one is the Xbox mixture, which I wish I can tell you I was good at, but my little brother always beats me up. The Xbox mixture is using WinRTC library to enable what they call a faster than light, their video streaming protocol that allows them to have a fast, clear, and sharp communication in the streaming called FTL. And that is completely built on the UWP and uses the WinRTC library to enable FTL. My second customer is the Mixed Reality HoloLens 2. The HoloLens 2 is an incredible experience to allow people to have remote support. So here is an example of someone that is in the field wearing a HoloLens 2. And they're able to have an expert under the cover using WebRTC to be able to get their help and having both their hands free to do the job on site. And they can also do file sharing through WebRTC too. So everything happening here is using WebRTC. So the third one is the Microsoft research team. And it's very, very incredible how they're doing a very, very important research to include children, especially children on the autism spectrum, to use video conferencing more comfortable and in a productive way. Because what it means for us to connect and use that technology is different from what it means for them to use it. And we want to include everyone, including people on the autism spectrum. So the very last thing I want to go over is the WinRTC architecture before I hand it into Augusta to go through the demos. So on the right side is the web developer platform, and what on the left is the Windows native platform, the powerful experience that we wanted to give our customers. So here on the right, we have a developer building a web app or a PWA, and that sits on a Chrome or Anaheim. And that sits on top of the Win32 apps, because Chrome and Anaheim are Win32 apps. And then this experience sits on top of the WebRTC.org. On the left is what we wanted to have for our customers. So we wanted to provide for them a XAML control, easy to have a WinRTC experience. So this is our WinRTC component. On top of it sits the XAML control. So here we have a developer building a Win32 app, and that sits on the WinRTC library, and then that sits on the WebRTC.org. The second one, we have a developer building a UWP app, and we kind of have the option to include a XAML control, so it can use the XAML control, or it can go straight to the WinRTC component, or it can actually skip all of these and go straight to the WebRTC.org. Or here, we have a developer building a React Native for Windows, and that uses the XAML control on top of the WinRTC for the best WinRTC or WebRTC experience. The last one here we have is the .NET app, and that kind of has the option to either use the XAML control or go to the WinRTC component. And here we have the last one is the Mixed Reality SDK. This is purely UWP, so kind of sits directly on the WebRTC.org. So all of that here on the left is sitting on the WebRTC.org, and that's when I said like everything that we're building doesn't really make sense if it doesn't align with the community standards. And here it shows you on the architecture how everything is lying on top of the WebRTC.org. So from here, I want to turn it to Augusto to go over the demos, and he's going to conclude with where we're going next and what you should expect moving forward. And from here, Augusto, take it away.
Thanks, Dina. Hi, I'm Augusto Rigetto. Today I'm going to show you how to add real-time communications capabilities to your Windows native apps. I'm going to start to give you a brief introduction of WebRTC. Then I'm going to talk about how to use WinRTC to improve your productivity by adding a XAML component to your UWP app. After that, I'm going to show you how to change the XAML component code for improving the camera resolution. Finally, I'm going to talk about the next steps for WinRTC. Let's get started. WebRTC is an overloaded term. It can refer to a set of JavaScript APIs defined by W3C to allow media to be sent and received by another web browser or device implementing the appropriate set of real-time protocols. It was developed in conjunction with an IETF group that resulted in a set of RFCs. W3C also published another set of APIs for allowing JavaScript apps to access local media devices. WebRTC also can refer to the open source code used as a reference implementation and shipped inside web browsers like Edge and Chrome. WinRTC is based upon the WebRTC reference implementation. Interoperability is one of the good outcomes of all these specs. There are specs about which codec should be supported and how network traversal should work. WebRTC is a peer-to-peer technology that allows applications built on top of WebRTC to scale very well. But if WebRTC is a peer-to-peer technology, how does one peer find another? Let's say Alice wants to talk to Bob. WebRTC spec doesn't define how Alice will find Bob. That means that Alice and Bob will have to find another way to coordinate the communication. One of the possible solutions is a signaling server. Bob and Alice connect to a signaling server and then start doing the peer-to-peer communication. But what if Bob and Alice are behind two different firewalls? In that case, Bob and Alice will have to use a stand server to figure it out what are their public IP addresses. After that, they might need to use a relay server to relay the communication. This sequence diagram shows the 72 steps required to establish a simple connection between two peers. I'm going to be using the rest of this presentation to show you how to implement these 72 steps. Nah, it's a short presentation. I don't have time for that. There must be a better way. Let's use WinRTC to improve your productivity. You will find the code for this demo and other sample code in our GitHub repo. In this demo, I'm going to build a UWP app with real-time communication capabilities from scratch. Let's get started. Let's open Visual Studio 2019 and create a new project. Let's create a blank app for C++ WinRTC projection. That one, it's for UWP. Let's name it My First WinRTC. Let's open the NuGet Package Manager. Here I'm changing to WinRTC because the NuGet packages are not public yet. Once they are become public, you are going to be able to find the NuGet as any other NuGet package. Here you can see the NuGet package is correspondent to the layers in the architecture diagram. This is the NuGet package containing the reference implementation that's a C++ code. This is a NuGet package containing a WinRT projections for reference implementation. And this NuGet package contains a demo component that uses WebRTC as signaling server. Let's install the demo component. Now let's open the XAML file. And let's add the namespace for the WinRTC XAML component. Microsoft WinRTC Simple Video Conferencing. Now let's remove these components that this project template had created for us. And now let's replace that 72 steps with a single line of code. That's it. The XAML component is done. Now let's add the header file that will be used for building that XAML component. This application will need access to webcam and microphone, also to internet connection as a server, because a peer-to-peer application. So let's add permissions to the UWP to the app manifest. So let's open the app manifest, go to capabilities, select internet client and server, webcam, and microphone. That's it. Let's close the app manifest. Now let's remove this code that was created by the project template. Now we just need to build. And the magic of addition will save you lots of minutes. After building, let's deploy the application to your machine and open Windows settings. Let's go to the privacy settings and allow the app to access the webcam and the microphone. And now let's start debugging. We just built a video conferencing application. You are going to see on the right side of your screen the output of the app that you just wrote. On the left side of your screen, you are going to see the output of my laptop here running the Edge web browser. So let's do it. Okay, the app has been launched and now is waiting for someone else to connect to this video conference. So the room ID that was registered in WebRTC is this number here. So let's go over my laptop and see and enter this room number here. And WebRTC. And let's type that in room number 16 33 02 99 77. And jump. It's over here. And we have it. Hello. Hello, WinRTC. Let's close everything. Oh, wait. What's this? Why the resolution is so bad? Oh, I know why. Poor camera settings is the reason of why the laptop image was so blocky. Unfortunately, the simple XAML control doesn't have an AUI for changing the camera settings. Since the code for building the XAML control is in GitHub, let's hard code another resolution to see if it improves the image sent to the laptop. First, let's remove the NuGet package that we added in the first demo. Okay, installed. Now let's open the code that generated that NuGet package. Okay, now let's add a reference to the project that we built. The app that we built now is using the code from GitHub. Now let's find the code in the XAML component that initializes the camera. So here, as you can see, so let's debug this code. This is the code that initializes the camera. Okay, so you can see that we have the camera capability here. The debugger says that the resolution is 640 by 480. That's quite low resolution. Let's change that. Let's stop debugging. And let's create a capability called requested capability and another one named resulting capability. So now let's define what we want for as a requested capability. Let's say the width is 1920, height is 1080, and we want 30 frames per second. Now let's call the API get best match the capability for the camera ID that we already have. With the let's pass the requested capability and you're going to get the resulting capability back. And let's use the resulting capability for when we start the capturing. Okay, so let's start debugging and keep the breakpoint over there. As you can see, the resulting capability now has 1920 by 1080. And now let's see the image quality improved. Okay, let's see if our change improved the resolution. So let's copy over the room ID to the WebRTC running on the web browser. So it's 16.0936 7702. And yep, much better now. Hello WinRTC. Bye bye. Okay, now let's talk about the next steps for WinRTC. We want to make WinRTC even better. Most of the devices these days have silicon specialized for encoding and decoding video. So we want to leverage that silicon for improving power efficiency. Another area that investment we want to focus is improving engineering excellence. So we want to have CI/CD, tests, and all that good stuff. We are also working on improvements for the WinRT abstraction layer and beefing up the XAML controls. We also want to have small binaries that can be shipped on devices that this binary size matters. And we also want to have more controls for other signaling providers. We also want to have samples and documentation for other platforms like Win32, .NET, React Native for Windows. And finally, we want to contribute our changes back upstream. But we cannot do this alone, so feel free to join us on our GitHub repo, and thanks for watching.